Hello friends, welcome to our channel Knowledge Amplifier, and in this particular video I am going to discuss one very interesting categorical data handling technique, okay, and that is called frequency encoding or count encoding. So this particular categorical data handling technique we generally use for those kind of categorical data which follows no order, okay, like for example colors, okay, yellow, green, blue. Suppose these three distinct values are present for the colors column in your data set. Now how you can map these to some particular numerical value so that you can apply machine learning model on this, right? That's what I am going to discuss. Already I have discussed one technique, that is one hot encoding. In that case what we have done, suppose I have three distinct colors, yellow, green and blue, then we create three different columns, okay, or sometime if there is only three possibility of color, then if we create two different column, yellow and green, that then also sufficient, because if one color is not yellow and green, then by default it is going to be the rest color, right? So like that we do one hot encoding. So one thing is clear, due to application of one hot encoding, what happens, that number of features increases by a huge amount, okay, and this sometimes creates problem, because in machine learning model, if the total number of features keep on increasing, obviously there is problem might appear, curse of dimensionality, there might be time and space complexity will increase for your model, all these things will happen, okay. That's why another technique is used for handling those kind of categorical data where the categorical data has no order, and that is basically frequency encoding. In this case what we do, in this case we map all the categorical value which have actually no comparison or which follows no order to one column only. In one hot encoding we map to multiple columns. Here we will map only one column, and in that column what we will do, we will map the categorical data to the corresponding frequency of that particular data, okay. Like suppose in our color column, yellow color is appearing 10 times, then wherever yellow is appearing, corresponding to that we will map the value 10, okay. So frequency encoding, right? So now I am going to discuss how we can do frequency encoding in MATLAB, okay. So I have taken one small data set. Let me just show you, which is having only categorical data in this particular scenario. Refund, okay. The next column is whether the person is single, married or divorced, okay. Yearly income, and then cheat, okay, right? See, you can understand all these are categorical data, string values. So in machine learning, in mathematical computation, we need to map this data to some number, okay. So that's why we use different encoding techniques. We have seen one hot encoding. Apart from that, if the data set, if the categorical data can be arranged in a order, okay, like good, bad, worse, like that time we can assign 0, 1, 2, like that order values we can give. That also we have seen, right? Now the concept comes how we can calculate the frequency for any particular categorical column, okay. For that, the MATLAB function is tabulate, okay. You write tabulate of our dataset is x, okay. So x dot suppose refund, okay. I am considering the first column only. If you hit enter, you'll be getting this output. See, the first column is what? First column is basically all the distinct values present in our x dot refund column, which is yes and no. And see, the next column is giving us the count value. For yes, 3 yeses appearing. You can see here one yes, here one yes, here one yes, and 7 no. 1, 2, 3, 4, 5, 6, 7. So 7 no is appearing here. Percentage is showing 30% yes, 70% no. Right? So what we have to do? So basically the first column we can say is giving us the total number of distinct possible categories is in our data set. So I am writing the code here because for frequency encoding direct inbuilt function is not present, okay. So I can write frequency equal to tabulate of my data set, okay. So whatever variable we want to give, suppose I want to encode the refund one, so tabulate of refund. First thing, calculate this particular statistics. Okay, then obviously we have to calculate first the size, because size will vary. The column numbers will be same, but row numbers will basically depend on total number of distinct possible categories, right? So first calculate that row column equal to size of my frequency, this one whatever we are getting here, right? So I hope up to this clear, right? Now what we have to do, we have to create one new column which is basically going to store our encoded values. Okay, so new column equal to, what we can do, we can, for the time being, we can calculate one column which is having same size, same length as our row. Okay, total number of rows present in our data set, and the column number is obviously going to be 1. Okay, so we can write size of our data set. Okay, so one column we are considering, we are actually interested in total number of rows. Okay, so we are extracting total number of rows using this one index and then giving 1, because column only one, right? New column whatever it is going to create, only one column will be present, right? So now what we can do, see what we will do here, we will use one for loop and we will iterate in this first column of the tabulate data, okay, which is basically storing all possible distinct categories. Okay, so for I equal to 1 colon, see here we have stored total number of rows of our this tabulated data, so we will write that in this for loop. Okay, then what we will do, we will, for each row we will calculate this count, okay, which is basically frequency. So this is going to be value part for our corresponding new column whatever we are going to create. So I am going to copy this. So frequency, from this we are going to take the second column. Okay, now can you tell me what is this data type? This is nothing but correct cell. Okay, because you can understand that this will by default return cell. Okay, or you can check like this, G equal to tabulate of x.Refund, and then you can simply write whose G. Okay, see class is cell. So in the cell data type, if we want to extract any particular data, we have to give second bracket or curly bracket, right? In that row, okay, this for loop is used for row, so we are traversing row wise. In that row, second column we are extracting. Okay, so it will give us the value, right? Then we need to fill this value. Suppose first one is yes, so all the part where yes is appearing, there we need to put this value. So first of all, we need to calculate those indexes where actually yes is appearing. So index is equal to, what I will do, I will convert my this particular column into categorical. Okay, so categorical of x.Refund. Okay, you can check the default data type for x.Refund, f equal to x.Refund and whose x. See, this is table data. Okay, so we are converting this to categorical, right? So categorical data, this should be equal to what? See, we are trying to find index, right? So this should be equal to yes or no. Okay, whatever row we are present in the iteration time, that particular one we are going to select. So this is present in the value part, which is first column. Okay, so what we will do, we will take the frequency output, and in that corresponding row, first column element we are going to find. See, I hope you can easily understand. So basically categorical x.Refund. So basically that particular data, whatever we want to apply encoding, in that whatever values are getting as yes, okay, initially yes, then no, we will be getting the index position corresponding to that, right? Then what we will do, we will impute this in the new column. Okay, new column in this indexes only, right? Indexes equal to this particular value, whatever we are extracting, that we are going to impute, right? So let's hope that the code should work. Control A, evaluate selection. Let's check. So yes should be filled with what? 3, and no should be filled with 7, because the frequency of yes is 3 and frequency of no is 7. See, we are getting this. Let us check once with like this x dot refund and then new call. Okay, I am writing like this. Dimension must agree x dot refund. Okay, so what we can do, we can convert this to categorical. Unable to concatenate a double array and a categorical array. Okay, right. So we can directly insert this new column in our data. Okay, x.Encoded equal to new call. I guess it will be better for comparison also. So now if I just write x and enter, if I check our data set, see one encoded column came, and if you compare, wherever yes is appearing, their encoded value is 3, wherever no is appearing, their encoded value is 7, because frequency of yes is 3, frequency of no is 7, right? As simple as that. Now let's check this one. Okay, right, just change the name whatever you want to encode. Cool. So if I just write x and enter, see all the encoded values are 0. Okay, why this is happening? Let's check. X dot encoded new column, x dot encoded equal to new column. So let me check frequency. So it should be replaced by 442, but it is replacing all with 0. New call. New call is all 0. Why this is happening? Okay, so here I have applied x dot refund. Here also I have to change. Sorry. Everywhere where you have used x dot refund, there you have to change the corresponding one. Okay. So now Control A, evaluate selection, and if you just write x and hit enter, see single is appearing how many times? 1, 2, 3 and 4. See, wherever single is appearing, there it is encoding as 4. Married is appearing how many times? 1, 2, 3 and 4. Okay, married also is replaced by 4, and divorced is appearing 1 and 2. So frequency of divorced is 2, so it is appearing 2 times. Now this is one of the major disadvantage of frequency encoding. See, actually after this kind of encoding, if frequency of two different categories are same, like here single and married are same, having same frequency, that is 4, so you cannot distinguish them. Okay, so the some amount of data we are basically losing here. So this encoding technique has this drawback. Remember this, although it is overcoming one major drawback of one hot encoding, that in case of one hot encoding, what is happening, that the total number of features is increasing by a huge amount. But in this case, what is happening, that if the frequencies of two different categories are same, that time your model might get confused. Okay, because two different categories are mapping to same value, right? So this is one of the major disadvantage of frequency encoding. So what we generally do, if we see that while applying one hot encoding, the total number of features are increased by a huge amount, that is if there are many distinct categories are present, that time we apply one hot encoding, and then many columns, new columns will come. On that we apply PCA, principal component analysis, right? Because that is dimensionality reduction technique. So that is also another possible way, right? So I hope you have understood this. Same code will be posted in the description box or in the comment section. If you want, you can check there. Thank you for watching.